Hello, everyone, and welcome to today's webinar on the art of the possible in 3D. Have you ever dreamed about finding an efficient way to work with aerial LiDAR data, BIM Revit, and 3D SketchUp models in ArcGIS Pro? Are you interested in incorporating your 3D models into ArcGIS Online, ArcGIS Urban, and ArcGIS Earth? If your answer is yes to any of these questions, then this webinar is for you. In this webinar, we'll demonstrate tips and tricks to implement 3D data across the ArcGIS platform. My name is Hannah. I'm a technical solutions specialist based out of Calgary, and I'm joined here today by my lovely colleague, Sapita, who is also in Calgary. Thanks for joining me today, Sapita. For those of you who haven't attended one of our webinars before, we're recording the session and we'll email you the recording afterwards along with the slides. We'll make sure as well to include a lot of fun and useful links and resources in this PowerPoint for you to take away. If you have any questions about the content we're presenting today, please use the Q&A panel. Be sure to also choose to ask all panelists. Type your question into the box and then hit send. We'll also pause throughout the webinar to take questions. Please feel free to type in your question at any time. And if Sapita and I can't take your question during the webinar, we'll be sure to follow up with you afterwards. We also create a blog post based on your answers from the questions, and we'll send it to you along with the slides after. Today's session will focus on several exciting and specific topics. We'll explore best practices for LiDAR. One of the examples is with feature extraction. We'll learn how to share 3D models in ArcGIS Earth and ArcGIS Urban. We'll show you how to use a 3D planning app to engage citizens in the urban planning process. And last but not least, we'll discover how organizations can incorporate 3D CAD data into ArcGIS indoors. Communities are changing rapidly due to increased development efforts. The ability to view the community in 3D can give internal stakeholders and the public a better understanding of what's happening in our cities, allowing for faster and more engaged decision-making processes. At the same time, organizations tend to struggle when creating and maintaining a 3D base map of their community that will enable the adoption of 3D visualization for a wide range of use cases, such as urban planning, emergency management, and real estate. That's why we wanted to deliver this webinar today, to introduce to you new and exciting ways of delivering projects, improving efficiencies, and providing evidence-based answers to the problems that you may be facing. In this webinar, we will introduce the 3D base map solution that includes a series of tools and workflows to leverage data such as LiDAR to author high-quality 3D base maps. This 3D base map can be used in all of ArcGIS Urban, ArcGIS Earth, and in web mapping applications. Let's start by talking about tips for working with your LiDAR data and review the tools and workflow for extracting 3D contents from it using the 3D base map solution. Airborne LiDAR, or light detection and ranging, is a remote sensing technique that uses lasers to determine distances to reflective surfaces. ArcGIS Pro supports LiDAR data provided as LAS or optimized LAS files. In other words, LAS files are an industry binary format for sharing your airborne data. Working with LiDAR data requires ArcGIS Pro Advanced with Spatial Analyst and the 3D Analyst extension. You can display your LAS points using RGB values from imagery. Colorized LAS geoprocessing tool applies colors and near-infrared values from imagery to the point cloud. We use this method for suitability analysis and environmental assessments. For example, to assess canopy density and investigate if the site is suitable for file collection with heavy equipment, you can apply colors to LAS points. In this way, you can plan for further exploration of your land without damaging the sensitive urban environment and also minimizing environmental impacts and safety risks along the way. This tool can be found in the Data Management Toolset under 3D Analyst Tools and requires a 3D Analyst extension. If you receive LiDAR data with a missing building classification, no worries here. Use the set LAS class codes using features to generate the building classification in your LAS file. We highly recommend using this tool if you have a building footprint. If you do not have a building footprint, you may want to use the Classify LAS Building geoprocessing tool. Detailed elevation layers can be extracted from the LiDAR data. LAS data set to raster tools can create elevation of the ground and elevation of features and buildings on top of the ground. The resolution of these rasters plays an essential and important role in generating accurate building roof forms. Now, to calculate and extract a precise roof form, be sure to apply the correct sampling value while generating your DEM and your DSM. You can find the sampling value in the property of your LAS file. Be sure to use the average point spacing for your cell size parameter in this tool. To extract roof forms, use the Extract Roof Form tool. We can find and download the custom script as part of a 3D basemap solution on the ArcGIS for Local Government app. To deploy the 3D basemap package, you will need ArcGIS Online with a creator user type, ArcGIS Pro 2.5 to 2.6 Advanced, along with ArcGIS Spatial Analyst and ArcGIS 3D Analyst extensions. Attributes such as building height, eave height, and roof form will be calculated and added to the building footprints polygon, and procedural rules are applied to create 3D roof structures. Just to note, you cannot share this 3D data with ArcGIS Online or perform editing and apply texture on them unless you convert them to multi-patch features first. Layer 3D to feature class exports feature layers with 3D display properties to multi-patch features. Multi-patch feature classes are used to define the exterior shell representation for 3D objects. They contain patches that can store texture, color, and transparency. Location and height of trees can also be extracted from classified LiDAR using vegetation extraction tools. The output of this tool is the point feature class, which can be symbolized using procedural rules. You can import 3D models to a multi-patch feature class. The supported formats here are 3D Studio Max, VRML, and GeoVRML, OpenFlight, Collada, and Wavefront OBJ models. However, to import large 3D model files, consider also using the Import 3D Files Geoprocessing tool. Sapita now has created an interesting video that covers best practices for preparing and extracting information from LiDAR. Let's take a look at it now.
Thank you, Hannah. I'm so excited to show you all the tools that Hannah mentioned in this slide. So when it's time to play with LiDAR in ArcGIS Pro, working with colorized LiDAR is a breeze. This is the colorized last dataset created for the city of Grand Prairie. With colorized LAS, you can apply RGB information from imagery to the LiDAR and create such a photorealistic display of your cloud point. Let's look at the colorized LAS geoprocessing tool. The required parameters are the LAS file and imagery. You also require defining a folder where the output last dataset will be written to. After running this tool, a new last dataset can be symbolized by RGB values. Let's move on to another tip. If you receive the last file that doesn't have a building classification, consider using set LAS class codes using features. This tool assigns building classification code to those LAS points that intersect the building footprint. Last dataset to raster is a tool that creates a digital elevation model and a digital surface model. Applying the correct sampling value helps to generate accurate roof form. You can find the sampling value in the property of your last file. DEM is a representation of the ground elevation. Use the layer with the appropriate filter properties set as the input to the tool. DSM represents elevation values for the objects over the surface. DSM and DEM are the required parameters for the -2. You can calculate normalized raster by subtracting DEM from DSM. This raster represents the height of object above the ground. ArcGIS Solutions app can deploy the 3D basemap solution in your ArcGIS Online organization. You can download the associated project package to access the Extract Roof Form tool. The required parameters for Extract Roof Form are DEM, DSM, and normalized raster dataset. The output will be a polygon that has 3D symbology. You can't share this 3D building polygon into ArcGIS Online or perform editing unless you convert it to a multi-patch feature. Layer 3D to feature class can convert these 3D polygon into a multi-patch feature. Select Object ID to enable editing and applying texture to each building individually. Let's move on to the Vegetation Extraction tool. This tool can be found in the 3D base map package and creates a multi-patch feature class and a point feature class to represent the location of trees. Procedural rules and 3D symbology styles can be applied to these points to display schematic and realistic 3D trees. Some of you are working with 3D models in 3D Studio Max, Claude, and Wavefront. One of the best practices for importing your 3D models is using the Model File tool. This tool imports the 3D models into the multi-patch features. I hope after this webinar you have fun exploring using these tools. Let's move on to the next step of our presentation, where we show you the best practices working with 3D objects in ArcGIS Pro. Back to you, Hannah.
Thank you, Sapide. That was wonderful. Thanks for that great demo. Okay, let's break to a question period here. So we got a couple of questions in for you. The first one is, how can we optimize LiDAR, Sapide, in ArcGIS Pro?
ArcGIS Pro cannot edit ZLAS file. If you wanted to work with optimized LAS, you have to decompress the ZLAS file back to LAS file to complete any edits on the points.
Okay. There's another one here. Is there any website that we can use to download free LiDAR from?
Some organizations upload their LiDAR data in their hub or open data site. You also can find free LiDAR data in the Canadian LiDAR data website. I will drop the URL in the chat window for your reference.
Wonderful. Okay, we're on to the next section now. Let's introduce the 3D functionalities in ArcGIS Pro that any GIS professional should know when working with 3D contents. Okay, so one of the main functionalities that any GIS professional we feel should know is the pixel editor. The pixel editor provides a fast and easy way that we can edit our classified raster and imagery. Pixel editor is available only with the image analyst extension, so take note. Replace pixels is a great tool in the pixel editor that allows you to cover a region with another block of pixels. Sapide will show us this tool in a demo shortly. You can export the geoprocessing tools that you've run for creating 3D buildings into a Python script or a model builder workflow that you can make automate your workflow with and make more efficient. You can send a Python snippet from a history entry to the Python window, and all data required to run the tools will be added to the Python window. We use this method a lot as a best practice for working with our LiDAR. Let's take a tour now of these functionalities. I'm just going to turn it over to Sapide and pass the ball over to her.
In this demo, it's share. I know. In this demo, I'm going to show you how the city planners, architects, and construction managers can use the 3D functionality to evaluate the appropriateness of the high-rise building in a community. As a city planner, I use LiDAR data to create 3D scene to evaluate the site. Some geoprocessing tools have been used for this conversion to automate repetitive tasks and save my workflow for the next project. I'm going to report these geoprocessing tools into a model builder. When we are working with LiDAR, sometimes it's a good idea to export our workflow into a Python window. The same Python workflows can be documented in ArcGIS Notebook. Then this notebook can be run in the hosted ArcGIS Notebook in ArcGIS Enterprise and ArcGIS Online. Let's evaluate the appropriateness of this proposed high-rise building over the vacant lot. The first thing we need to do is assessing the shadow impact of this building over the community. This can be done using an animation timeline. It seems this building doesn't shade on parks, school, and restriction areas. The next step is identifying the best location for a parking area using an interactive cut and fill tool. This tool can calculate the volumetric displacement required to level the ground. Green represents the volume below the surface and purple represents the volume above the ground. As you see, 342 fill volume required for the first location and 18 cubic meter for this area. So it seems this area will be the least cost effective for building a visitor parking. How about taking this polygon and integrate it with this imagery using Pixel Editor? Replace Pixels is the tool that manipulates the pixel values of any selected region and replaces them with other existing pixels. In this way, I can share the location of the visitor parking with construction managers for approval. Last but not least, we can enhance our design by rendering animated water to make this site a little bit more dramatic. New styles for the 3D symbols have been added to ArcGIS Pro to support infrastructure, recreation, and transportation system style. It gives a more realistic view of the design. I can't wait to see how these 3D functionalities enhance your work. Turn it back to you, Hannah.
Great, thank you, Sapide. That was awesome to see ArcGIS Pro come to life with those 3D objects. Okay, all right, so BIM interoperability has been one of the most considerable requests by GIS users. BIM is used to capture detailed information about our assets, and GIS provides information about how those assets operate and are used in a spatial context. In ArcGIS Pro, we have two tools that make working with Revit files a breeze. BIM File Geodatabase is a tool that imports the contents of one or more BIM file workspaces into a geodatabase featured dataset. And the Make Building Layer tool also creates a composite building layer from the output of the BIM File to Geodatabase. You can create a building scene layer with building layers. Revit or feature classes generated from the BIM File to Geodatabase geoprocessing tool. In this way, we can publish them into ArcGIS Online as a scene layer. Sapia has now created a video to show us how we can combine multiple Revit files into a new featured data set and create a building layer from it. Let's take a look at this now.
Revit files. In this, with the BIM to Geodatabase tool, we can combine these Revit files into a new feature data set. Now that our model data is in the feature data set, we can merge additional content from other Revit files or GIS feature classes. We have complete control over what is and is not in this feature data set. The next tool creates a composite building layer from this feature data set and automatically classifies these features into their specific systems and attaches all the symbologies that come from Revit files. This building layer will not persist after closing the project unless the document is saved. If you wanted to share your building layer with others, you can save it as a layer file. If you are interested in publishing your building layer to the cloud, you can use a Create Building Scene Layer package to generate an SLPK file. Scene layer packages can be published as a web scene layer to ArcGIS Online. This is the 3D scene that is created from Building Scene Layer package. Back to you, Hannah.
Great, thank you, Sapide. Okay, so we have some more questions here, another section we're going to break. So we've got the first question. When can we edit and explore voxel layers in ArcGIS Pro?
I have a good news. At Pro 2.6, we can explore and manipulate large multidimensional space-time voxel cubes. Usually, they have net CDF format. The final release of Pro 2.6 would be at the end of this month. In the next release, we can share voxel scene layers across the platform for using web, desktop, and mobile apps. With new voxel layers, you can represent multidimensional spatial and temporal phenomena as 3D volumetric visualization. For example, you can create amazing visualization for atmospheric data, geological subsurface models, oceanographic data, or a space type cube. I hope I answered this question.
Okay, no, that was excellent. All right, we've got one more here for you. Is the 3D Analyst extension required for working with BIM Revit models?
The answer is no, you don't need any extension. The ArcGIS 3D Analyst extension is only required for performing 3D analysis. If you wanted to run geoprocessing tools in the 3D Analyst toolbox, then you need the 3D Analyst extension.
Awesome. Okay, we're going to move to the next section now of the webinar, where we'll see how to share 3D models in ArcGIS Online so that they can be hosted in ArcGIS Earth and ArcGIS Urban. To start, a scene layer is a type of layer that is optimized for displaying large amounts of 3D data in a scene. A scene layer displays points, LiDAR point clouds, and 3D objects. When it is shared to ArcGIS Enterprise or ArcGIS Online, a scene layer then becomes a web scene layer. One of the methods for sharing your 3D objects is share it as a web layer. Before publishing your 3D object as a scene layer, however, we recommend adding your buildings as multi-patches and your tree point data to a local scene in ArcGIS Pro and then publishing them as a web layer. The second consideration to take into mind is to make sure that the elevation property of your 3D buildings is set to an absolute height. The third recommendation is that the procedural symbols applied to the multi-patch feature should be downgraded when you publish them. However, this method does preserve the 3D symbology style applied to the point feature class, such as trees. Use this method of sharing when you would like to upload your 3D trees and 3D building multi-patch features with ArcGIS Urban and JavaScript applications. Just a tip to not use this method when you're working with ArcGIS Earth. A 3D object scene layer can represent and visualize objects such as buildings that are explicitly modeled in 3 dimensions. A 3D object scene layer can be created quite easily using this Create 3D Object Scene Layer Package geoprocessing tool, which generates a scene layer package on a disk for you. This file can then be uploaded to ArcGIS Enterprise or ArcGIS Online as a 3D object hosted scene layer. Keep in mind, there is another excellent way to create a 3D object scene layer, which is using Share It as a Web Scene. Let me give you a couple of hints here. The first is this tool supports only the multi-patch features layer that does not have procedural symbology applied. Also, the elevation of the input multi-patch layers must be defined with absolute height. Sabina and I recommend using this method when working with ArcGIS Earth because only unsupported scene layers for ArcGIS Earth is 3D object hosted scene layer. You can also use this sharing method when you would like to upload your 3D building multi-patches features to ArcGIS Urban. Building scene layers allow you to share 3D content sourced from BIM Revit files across the ArcGIS platform. You can create a building scene layer with Revit data or feature classes generated from the BIM File to GeoDatabase geoprocessing tool. Create building scene layer package tools create a scene layer package. This file can then be uploaded to ArcGIS Enterprise or ArcGIS Online to be published as a web scene layer. We recommend using this sharing method to load your BIM data into ArcGIS Urban. However, only an overview layer of the building scene layer representing the exterior shell of your Revit model will be hosted in ArcGIS Online. The individual category layers, such as trees, can then be published using the Create 3D Object Scene Layer package tool. They must first be copied to the viewed database and then added as a standalone multi-patch feature class to your scene. The building scene layer is an unsupported layer type in ArcGIS Earth, but it can be used in ArcGIS Urban and JavaScript API applications. We are very excited to show you how we can implement the 3D base map into ArcGIS Urban. Let's start by exploring what ArcGIS Urban even is and how you can benefit from it.
So let's pause here, and I'm so excited to show you the different method of sharing 3D content into ArcGIS Online. In this demo, I will show you how you can create a scene layer for hosting in ArcGIS Earth, ArcGIS Urban, and JavaScript API application. One of the methods for sharing your 3D objects is share as a web layer. Publishing multi-patch or 3-point feature class in this way creates a hosted scene layer and a related hosted feature layer. Use this method of sharing when you would like to upload your 3D trees and 3D building multi-patch features with ArcGIS Urban and JavaScript API application. The second method for sharing your multi-patch features is using the Create 3D Object Scene Layer package tool to generate a scene layer package on a disk. This SLPK file can be uploaded to ArcGIS Online as a 3D object hosted scene layer. We recommend using this method when you are working with ArcGIS Earth. Publishing your 3D content as a web scene is another great way to create 3D scene layers. Let me show you another method that works with ArcGIS Earth. If you publish hosted feature layer, such as 3 points in your ArcGIS Online, you may want to apply symbology styles to your 3D object scene layers and save them as a web scene. ArcGIS Earth is working with this type of data very well. Let's move on to the building scene layer created from BIM Revit. A building scene layer contains an overview and full mode structures. The overview represents the exterior shell categories. The building scene layer is stored on disk as a package and can be uploaded to ArcGIS Online organization as a scene layer. However, by default, only your overview layer is shown in the web scene. To upload the individual category layers such as trees and furniture, you can use multi-patch feature generated by BIM to GeoDatabase tool. Using Create 3D Object Scene Layer package tool helps you create a SLPK file that can be uploaded as a scene layer to ArcGIS Online. Then you can add your overview layers to those category layers and share them with ArcGIS Urban, ArcGIS Earth, and web application. Now turn it back to you, Hannah.
Thank you, Sapide. Thanks for showing us how seamlessly that we can integrate those data types. Let's skip back to ArcGIS Urban now and talk about this solution. ArcGIS Urban is a web-based solution that uses a 3D experience to view, design, manage, and measure urban development projects. This environment creates a place for planners, developers, and stakeholders to collaborate on the desired community visions. ArcGIS Urban improves planning and productivity by simplifying the zoning and planning processes. It helps visualize projects citywide throughout the project lifecycle and it assists in communicating trends and performance and indicators. Another essential benefit of Urban is it increases community engagement using 3D visual representations through a simple web-based solution. To work with ArcGIS Urban, you will need an ArcGIS Urban license and an ArcGIS Online account with a publisher or creator role. These are the essential pieces that you'll need to get started. Urban can design 3D scenarios. The first step to start is by establishing a 3D base map in ArcGIS Pro and publishing it as a scene layer or a web scene in ArcGIS Online. The second step is publishing your zoning and parcel data into ArcGIS Online. Projects are development projects that are currently in the review process that need to be made available. Project data, on the other hand, are points and polygons that include the project's name, the project status, and the start and end days of that project. Sapita will now give you a quick and easy demo of what ArcGIS Urban is and how a 3D base map and Revit model can be added to ArcGIS Urban to enhance urban planning. I'm going to pass the ball over to you now, Sapita.
I'm very interested in showcasing the 3D functionalities in ArcGIS Urban. So in this demo, I'm going to show you how ArcGIS Urban can help city planners to orchestrate the urban planning development. ArcGIS Urban is a web-based, an extension of ArcGIS Online. You will need ArcGIS Urban license and ArcGIS Online account with a publisher or creator rule. Depending on your username, it determines what you can see and edit on Urban. This demo is located in the city of Grand Prairie and is showing the 3D base map created from LiDAR. Urban contains 3 components: projects, plans, and indicators. Projects provide a way to manage short-term development at the parcel level. Each project is marked with an icon that indicates the project's status. Let's look at the project that has been submitted but not yet approved, like a Grand Prairie Community Development. The detailed information about the project's name, its start and end dates, scenario information, and the list of the project's feedback are added in this card. There are 2 scenarios in this project, a proposed high-rise building and a proposed commercial buildings. Scenario 0 is the existing condition of the project site without the proposed buildings. It's common practice to analyze the line of sight from certain viewpoints within and around a development. For example, we can evaluate the view from this new building development to the lake and determine whether the view is obscured by other buildings. The tool uses red lines to represent the obscured view and green lines represent visible view. Another, the most exciting capability is the ability to edit projects. Urban allows you to quickly sketch buildings, place trees, vehicles, street furniture, and ground visualizations. For example, you can propose another building and move or modify all its edges. A plan is made up of individual small-scale projects. Urban has 2 types of plans, zoning and land use. Let's explore a high-rise building plan to validate the proposal building scenario against the existing land use and the zoning codes to ensure feasibility. In zoning plan, we can visualize the required zoning parameters, combination of the zoning code restrictions, maximum buildable height, and allowed space use. In the development, we can see the information about the building regulations, setback parameters, as well as parcel and building information. The capacity metrics can be used to compare design scenarios. For example, we can explore how the proposed scenario increases the population of the area, energy use, future water or wastewater consumptions. We can display them in the capacity dashboard and export them to Excel for further analysis. Land use plan. allows us to explore the existing and future land use boundaries, to modify future land use scenario. One of the main components of urban is indicator. An indicator provides analytics to your urban plans and projects. Grand Prairie flood hazard is one of the examples of custom indicator that delineates flood hazard areas and the area of the city that are at risk of flood along the Bear Creek Reservoir. Let's take a look to the Data Manager. Data Manager is a tool that allows you to add, edit, and configure your data. Only users that have editing privileges can see the Data Manager. On the Setting tab, it's recommended to add a custom-based layers that includes the 3D layers that are published as a web scene from ArcGIS Pro. If you would like to get feedback from the public on certain projects and plans, we can enable public engagement. You can also turn on Street View. In a Street View, you can explore your city from a street level perspective and compare what you can see on the street today to your design proposal. You can load your city's land use, zoning, space use type information into your Data Manager. You can edit your city buildings types or create your own. A building type will allow you to visualize what a typical structure for the specific type might look like. You can see the list of plans and projects in your urban and quickly edit or add a new scenario to them. Adding design context layers to a project allows you to import specific layers that give greater detail and understanding to the project or to the scenario you are editing. Design context layers can be configured per project as well as per scenario. In this demo, we explored how ArcGIS Urban components can enhance the urban planning process. Back to you, Hannah.
Awesome. Thanks, Sapide. Now, if we're interested in working with ArcGIS Urban, our ears have really perked up on using this product after the really informative demo that Sapide has just given us. We've attached the resources that you need to start learning more about this product to the materials. Please also get in touch with us anytime if you're interested in working more with ArcGIS Urban and you'd like some more information. So we've got a question period here following this latest demo. The first one I see here is, Sapide, can Urban be used with ArcGIS Enterprise Portal?
No, Urban is currently only available for ArcGIS Online, but stay tuned for the release of ArcGIS Urban API. Urban API is in beta version and is coming soon.
Oh, that sounds exciting. I can't wait for that. The second question is, how does Urban affect my ArcGIS Online credits? So does a larger city consume more credits than a smaller one?
The answer is a larger city doesn't necessarily consume more credits. The credit consumption depends on the number and size of plans, projects, and indicators that are stored in your urban. The more features that are stored in ArcGIS Online, the more credits are consumed for storing them.
All right, thank you for that. We just have one more here. So can students use Urban on campus without purchasing a license of it?
The answer is yes. Urban is a part of education institution agreement. With the educational license, universities and the school can make licenses available for students for classes.
All right, on to the next section here after the questions. So it's time to show you now how we can implement the 3D base map into ArcGIS Earth. Let's start by exploring what ArcGIS Earth is, its definition, and how we can benefit from this solution. ArcGIS Earth is an interactive 3D experience that we use to plan, visualize, and evaluate events on the globe. It provides an easy-to-use interface to collaborate with 3D data for research, planning, and supporting time-sensitive briefings. ArcGIS Earth has iOS, Android, and Windows versions, and they are all free to download and use. ArcGIS Earth allows you to use various items from ArcGIS Online, ArcGIS Enterprise, local data, and even web services. Supported local data includes shapefiles, KMLs, and KMZ files. Also, text and CSV files that contain location coordinates or addresses. You can drag and drop these local files right into the map display, and off you go. ArcGIS Earth only ingests the 3D object scene layer, to note. It also supports raster file formats such as PNG and GeoTIFF, and it assists you with uploading your as-built drawings. Let's take a tour now of this exciting product. Over to you, Sapide.
Thank you, Hannah. I think it would be great if I can show you some of the 2D and 3D functionalities in ArcGIS Earth that any GIS professional should know. In this demo, I will show you how ArcGIS Earth provides an easy-to-use interface for quickly exploring your proposed development. With ArcGIS Earth, you can reach your 3D base map and 3D object scene layer from ArcGIS Online. It provides an immersive 3D experience for performing interactive analysis. ArcGIS Earth supports 3 interactive analysis tools. The Elevation Profile tool allows you to create a profile graph to visualize elevation change over the landscape. Also, you can leverage interactive viewshed to understand viewshed visibility for proposed buildings from an observer by creating an animation view from the road. The blue represents visible view, and the pink represents obscured view. I have another good news. You can view your local file data such as KML or KMZ in ArcGIS Earth. In this way, you can evaluate the appropriateness of your design. For example, by overlaying sewer lines and manholes, you can assess the possibility of having lake in this landscape. To report your observation, you can send an email to your planner department for reassessing the design. In this demo, we explore how ArcGIS Earth can work seamlessly with our 3D base map to enhance our organization workflow. Turn it back to you, Hannah.
Thank you, Sapide. I really like to see how seamlessly you could even add those KML files right into ArcGIS Earth and get going right away on your workflow. That was really neat. All right, so if we're interested in working with ArcGIS Earth, we've also attached the resources here that you may need and would like to dip into when you start learning more about this product. Please get in touch with us also if you're interested in using ArcGIS Earth. So we have another question period here. Let's break. The first one, Sapide, that I see is how do customers get a hold of ArcGIS Earth in the first place?
ArcGIS Earth is available for download on desktop on the ArcGIS Earth product page. ArcGIS Earth for mobile is available on Google Play and App Store.
Okay, great. The next question here is, can we use ArcGIS Earth on an iPad or on an Android tablet?
The answer is yes. ArcGIS Earth works on iPad and Android tablets.
That is wonderful news. And the last question here is, how do I add local files to ArcGIS Earth on, say, a mobile device?
You need to manually copy over local files and data needed for the field to your mobile device. For iOS device, you will need to download iTunes to transfer files to ArcGIS Earth document. For Android devices, you need a USB cable to transfer files to your local devices.
Great, thanks, Sapide. Let's move on to the next section now. So if you guys, if anyone in the audience today are a developer and you don't have access to a license for ArcGIS Urban, well, no worries. This section of the webinar is for you. In this section, we will show you how to build a participatory planning app. Participatory planning is an interactive 3D web application that enables citizens to participate in urban planning and design in their community using the ArcGIS API for JavaScript. Any smart city can use this application to include community visions about a new planning process by giving everyone an equal opportunity to get involved with new development occurring in the city. A link for a live version of the app and the source code has been attached in the slides here for you. They're also both available on GitHub. Sapita has now created a video and will show us how to use this application and how it takes 3D base maps to provide an implementation for engaging our citizens in urban planning and design. I'm going to pass the ball over to you now, Sapita.
Thank you, Hannah. I'm so excited to show how to build a 3D demo app used for participatory planning in a few steps. In this demo, I will show you how you can use the ArcGIS API for JavaScript application to showcase the participatory planning application and how this application uses a 3D base map to support a new development process. This is the city of Grand Prairie. Through this application, citizens participate in the planning and design of landscape by suggesting the design of lawn, lake, and trees. Also, they can submit their opinion about the building they would like to see in their community. Ultimately, they can share their design with the city planners. Let me show you how you can configure your own application. You can download the application source code from GitHub. In the setting file, you can modify the web scene ID with your 3D base map ID and alter the planning area parameter with the web Mercator coordinates of your 3D base map. I hope this demo motivates you to explore this application. Turn it back to you, Hannah.
Thanks, Sapita. All right, now we're going to break and go to the last, well, not break, but continue on and go to our last section for the day, where we'll get to see how CAD data can be transformed and further worked on and manipulated in the form of a realistic 3D ArcGIS Indoors data model. First of all, let's ask ourselves, what is Indoors? Well, ArcGIS Indoors is a GIS data-driven solution that enables building owners to model their building space so that people can operate and use these buildings more effectively. ArcGIS Indoors provides a fully equipped enterprise suite for locating indoor occupants in places, facilitating directions in and between buildings, and managing geotagged service requests. ArcGIS Indoors is being offered as a standalone GIS and is typically deployed on a customer's infrastructure and configured to support indoor mapping and positioning. Indoors provides you with a data model that integrates building operational data and building schematics. Organizations can use Indoors to, for example, provide Indoors maps and wayfinding apps that enable users to navigate to points of interest, show the locations and status of people, offices, and conference rooms, collect service requests through mobile applications, which support indoor positioning, use indoor location tracking and geofencing to create real-time indoor maps and dashboards, and last but not least, to integrate operational data and building floor plans into a single view or point of reference. Now, what are some of the benefits of using a solution like this? Well, using ArcGIS Indoors, for example, organizations can monitor the personnel and situations on site through a common operating picture for all buildings, improve visitor satisfaction as well by making it easier to get around their buildings, also increase productivity by giving their employees the information they need to do their jobs. We can streamline maintenance activities by enabling these staff to locate and respond to service requests almost immediately. And also, we can improve space planning by using Indoors maps to allocate and manage resources. Let's take a tour now of this exciting solution. The Indoors data and web application creation workflow consists of a CAD to GIS data conversion, followed by the generation of the network and Indoors information model, and the feature classes participating in that model. And lastly, the indoors web map and scene, which are both shared to the online organization or your instance of ArcGIS Enterprise. A set of maps and scenes are typically created in the Pro project as a best practice to organize the indoors map, scenes, and data during the data conversion and map production phase. The primary building blocks of any indoors app include the network layers that get shared to the portal as a network service, along with your indoors data in the indoors database, or AIM, and the indoors map and scene. And optionally, the Survey 123 form can be embedded and used to streamline and digitize those service requests. The first important geoprocessing tool for indoors data creation is the Create Indoors Database tool. The inputs to this tool will be the desired input geodatabase or workspace within the indoors schema will be created in it. Please note here that this can be a file type geodatabase or an SDE or enterprise geodatabase. And as the last step before running this tool, please be sure to select the option to create the indoors network features, specifically if you're interested in using the apps for directions, wayfinding, or routing to various locations within your buildings. The output of the Create Indoors Database tool will essentially be an empty file geodatabase with the indoors schema in place. This schema is ready to go and ready to be populated with the data that comes in from the source CAD files and file conversion. When the incoming CAD layers are converted into the indoors geodatabase format, the process then outputs a bunch of people points, realistically in 3D, and points of interest feature classes, and not to mention the facilities, details, units, and levels feature classes, which become the 3D building. Once we have created the empty geodatabase, the Floor Plan to Indoors tool is then run to populate the indoors geodatabase with the attribute information coming in from our source CAD data. Work has been done ahead of this demo to insert the CAD layer attributes into what is called an Excel mapping template file. When all the indoors data has then been imported into the indoors geodatabase and editing of the points of interest and people attributes is complete, the indoors map and scene can then be shared to your portal. This is done using the Share as Web Scene tool, using Pro's ribbon at the top for the indoor scene, and similarly, the Share as Web Map tool if you'd like to embed a web map in the application. Once the web map and web scene and indoors network have been shared to your portal, you can go ahead and configure your indoors web app. Indoors web applications have traditionally and more commonly been hosted inside the ArcGIS Enterprise, but there is also the option to license your ArcGIS Online organizations to even host and run these indoors applications. When the appropriate steps have been taken to make the indoors template from Esri available as a configurable app, it will then appear in your configurable app menu, and a new indoors web app can then be created in your portal quite easily by selecting the Create New button, followed by specifying to use an app template. When the time has then come to configure the application and put your inputs in, the user can select the desired indoors web map and desired indoors web scene that they would like to feature. In addition to the previously shared network services, which include the route and closest facility layers, you will also have the option to embed a Survey 123 form, also known as the 311 form. This 311 form is able to link or integrate digitally tracked service or maintenance requests into the application. As a last step in the demo today, I'm going to show you an example of an indoors application that features Canadian data set in Toronto. This data has already been converted to an indoors database and published to the ArcGIS Enterprise. Once the application has been properly configured, you'll be able to start using it for navigation and to search the building for places of interest, like meeting rooms or conference rooms, for example, or for any of your colleagues working in and around your building and their offices. The primary features of the indoors web app are, of course, and where it shines, its wayfinding and searching capabilities. If I wanted to locate a colleague of mine in the Toronto office, I can simply use the People Points feature class, which becomes our Explore panel, and the application's search function to show me where their office is located. If I wanted to then, say, make a stop at the nearest cafe for lunch, I can use Indoors and the Directions panel to specify the location of that cafe and show me where I need to go. The indoors web applications are also configured to support different modes of transportation. These stem from the workflow where the user generates the network layers in ArcGIS Pro. These network layers are comprised of vertical transitions like elevators and stairways and horizontal pathways. So the modes include walking and even wheelchair mode, which support accessibility needs. And last but certainly not least, indoors gives us the ability to navigate our buildings between or across floors, as the network data sets that get generated in Pro can be built for multiple floor buildings in the same fashion as they would for a single floor. Sapita and I are so excited to see how you choose to configure and leverage ArcGIS indoors for your business needs.
Thank you, Hannah. We got some question for you related to your presentation, and I wanted to continue the rest of the PowerPoint by, if you share and make me presenter, Hannah, I can continue. Thank you, Hannah. Okay, there are a couple of questions here, Hannah. Is ArcGIS Indoors available for ArcGIS Online or just come as a solution with ArcGIS Enterprise?
Hi, yes, this is good news. So with the latest release of ArcGIS Online, ArcGIS Indoors is now also available as a SaaS offering. So ArcGIS Indoors is also available with the SaaS offering of ArcGIS Online. This comes as an alternative to the on-premises deployment of Indoors with Enterprise.
Okay, make me presenter, Hannah. Thank you. And I think we are reaching to the end of our webinar. To summarize, in this webinar, we reviewed the best practices for working with LiDAR and BIM Revit, and we showcased the steps for sharing your published 3D base map in ArcGIS Earth, ArcGIS Urban, and JavaScript applications. Also, we discovered how organizations can incorporate 3D CAD data into ArcGIS Indoor. We have 3 upcoming training classes. If you are brand new to ArcGIS Desktop, we recommend migrating from ArcMap to ArcGIS Pro. Also, there are 2 upcoming webinars available to register in the ArcGIS and ISRI Canada website. There are some available resources that you can use to learn more about the ISRI products. And we wanted to thank you for taking the time out of your day and participating in today's webinar. We will email you a recording of the webinar shortly, as well as a PDF of the slides. For those of you that we couldn't answer your questions, we will create a blog post from your item, and we will email you along with the recording of the webinar. Please stay tuned. We would also like to get your thoughts on the presentation, so please fill out the survey that comes up when you exit the webinar. Have a great day.